everyone for joining me this evening. Before I get started, I just want to thank both CodeSmith and SingleSprout for sponsoring this talk. And without further ado, let's jump in. So to kick things off, I want to address kind of the base question of what is a web server? I think most of you are probably familiar with the client-server model that the internet as we know it is built on. And I think in the most basic terms, you could describe a web server as something that stores content for a website and delivers it to clients that request it. But I think there's quite a bit of nuance to what the term web server actually means, and I want to unpack that a bit. I think for many of us, when we think of web servers, we think of these kind of physical computers, the hardware that lives in huge data centers packed into towers like this. And that is accurate. This physical computer is a web server. The computer that actually stores the HTML documents, the images, the CSS style sheets, all of those things that are part of your application and stored on a computer, yes, that is a web server. But there's also another side of web servers that work, and it works together with the hardware, which is web server software. So when we refer to the term web server, it typically means both the software and hardware that are working together in order to fulfill that activity of actually accepting the requests and preparing responses to the clients. And so just jumping in a little bit more detail here on the web server software, its core purpose is, as I mentioned, being able to handle requests and responses that are coming in across the hypertext transfer protocol, HTTP or HTTPS. And many cases, web server software also is able to handle simple mail transfer protocol and file transfer protocol requests as well. So those are other types of data transfer, as you can guess, for email and larger files respectively. And so this web server software is where we're going to focus on for today's discussion. And you can think of all of those physical computers and the hardware image that you may have in your mind as running some form of this software that we're going to talk about. So every web server computer runs some software of this type. Some of the big players that we'll go into more detail on shortly are kind of shown here across the bottom. So the Microsoft Internet Information Services. This is a kind of proprietary and paid web server software that Microsoft manages. NGINX, that's the green logo there, and Apache. These are the two biggest open source web server softwares out there on the market. And then Google Global Web Server is another big player, but actually it's interesting because GWS is a proprietary software that's only used within the Google network, but it's also fulfilling that web server software functionality. So what are the kind of common features and what does a web server software actually do? There's first kind of like the table stakes base set of features that all web server software is able to deliver on. And that's first support for one or more versions of the HTTP protocol in order to actually accept requests and then send responses back out to clients that are making those requests. Logging is another common feature for kind of baseline web servers because I think in terms of both the requests that are coming in from the clients as well as the responses that are being sent back out by the server, that data logging is very important for both security and statistical analytical purposes later on as you want to evaluate the performance of your application, server, etc. Some common features that are kind of built on top of the core baseline web server functionalities include things like authentication. So, optional support for authorizing certain users to be able to access some or all parts of particular websites. Bandwidth throttling. So, for example, this may mean limiting the speed of certain content responses if that means that the network is close to being overloaded. So they may slow the speed down for particular requests in order to keep it up for as many clients as possible. Virtual hosting is another common kind of add-on feature, which basically allows a given web server to host and serve many different websites, domains, using only one IP address. This is certainly not exhaustive, but gives you a sense of kind of the common features offered by web servers. So now we kind of talked a bit about the what. I think want to touch now on the how, or the how is performance measured for a web server. And I think as you might imagine, speed is really the name of the game here. And we'll kind of go through a few of the common performance metrics that are looked at when measuring web servers. So first, on the far left here, requests per second. So literally the number of requests that a web server is able to respond to in a given second. And we're talking, typical web servers are in the hundreds or thousands of requests per second. So want that to be, higher is better. The second one, throughput in bytes per second. So this is looking at the actual amount and size of data that is able to be transferred and responded to per second. Again, the more the better. There's often a trade-off between number of requests, so the far left, and the actual size of data that can be throughput, but those are kind of metrics that often go hand in hand. And then average response time. So just trying to understand, how long does it take for a given server to respond to various numbers of requests, various number of concurrent requests, and various requests of various sizes. So large, gig plus or several kilobytes. Those are all part of the spectrum of performance measurement that we typically look at with web servers. And so now I want to shift gears a bit to look at the actual kind of market landscape of web servers. Since the internet began, essentially, about 25 years ago in the mid-90s, you'll see here that the market share of all websites, so this is data being collected by an industry player called Netcraft, who does, actually, I think it looks like almost monthly web servers of billions of websites, basically all the websites that exist in the world. They're trying to sample and see which technologies are being used by the websites. And for most of the 2000s, Apache web server has been dominant. And so you can see here, as of December 2010, about 60% of websites were hosted using Apache. The Microsoft IIS was second with about 22%. The green line, which is just starting, so NGINX, that's one we'll deep dive into shortly. Here is about 7%. It only launched in 2004, so unsurprising to have a relatively low share. I think what is surprising is when we jump ahead another 15 years or so. And so if we look at the 2021 statistics for the same survey, you can see that NGINX has grown substantially and is now the primary web server software out there that is being used by most websites. Apache is still around, has certainly lost some share, but still second place. And then kind of the other players are making up much of the difference. So we're going to deep dive into the Apache and NGINX software. First, Apache. As I mentioned, this was launched in 1995. So this is like basically at the beginning of the internet, shortly after the very first web server was created by CERN. It is open source and supports nearly all operating systems. And that's actually one of the most appealing parts about it. It's very compatible with pretty much everything out there. It has a modular design. So the kind of core web server exists and performs the main duties of HTTP request and response handling. But you can choose to configure your Apache server to use whatever selection of modules you would like. So examples of modules, kind of like what I was talking about earlier, could be a virtual hosting module or an authorization module. And so Apache is well known for being very easy to configure these things. So if you want to use them, great, just kind of add it to your config file. If you don't want to use it, then you have a lighter weight solution. So that option value, I think, is greatly appreciated. And it uses a process-driven architecture. So with Apache, a new thread or process is actually created for each network connection that is made. And that means that while a given thread is kind of handling a request, it is blocked for unable to be used for any other activities. On the one hand, this works well because Apache is known for being a very powerful server and able to handle more complex requests, but it does prove challenging if you are expecting a large number of requests, because there's blocking issues that can arise as the number of requests increase. But that's kind of the basics on Apache server, which really kind of powered the early generation of websites in the world. But as I kind of alluded to, as the number and size of the internet accelerated over the past, call it 20 years, that proved to be challenging for Apache in terms of scaling. On the left-hand side here, you can see the number of internet users, which, if you think about it in very simple terms, the more people that are on the internet, literally the more absolute number of requests by number of people. And then, each of those people are making more requests per person, that kind of thing. And then on the right side here, you can see the average page size in terms of kilobytes. And the reason why this is also important is the larger a given page, the more objects there probably are on that page, and therefore the more requests, HTTP requests that need to be made in order to properly render. So both of these two things combined prove challenging for that Apache structure where a single thread or process is designed to only handle one request. This kind of multiplies and becomes very, very CPU intensive, eats up a lot of memory if you have to handle many. And that is where NGINX really stepped into the scene. It was originally developed in 2002 by Igor Sisev, who is a Russian systems engineer who was working for a website that was expecting a large volume of traffic. And so it was developed in 2002, then open sourced in 2004. It supports most operating systems. I think Apache does edge out NGINX in this dimension. For example, NGINX works with Windows, but I think doesn't run quite as efficiently. But NGINX is really designed for high concurrency, so being able to handle many simultaneous requests at the same time in order to optimize performance. And so it is structured using an event-driven, asynchronous, and non-blocking architecture. So we'll kind of deep dive into each of those. So on the event-driven side of things, that means that there are signals given for the initiation and the completion of a given process, which means that if a given resource is not currently working on a process, then it can be deployed on other tasks. So that is the event-driven side of things. And then the asynchronous, non-blocking side of it means that threads can be executed concurrently without blocking each other. Basically, you can handle multiple requests through kind of, if you see the diagram on the right here, NGINX is structured with multiple child processes that are linked to the overall master process. And each child process can handle thousands of requests on its own. So that's kind of the high-level comparison of Apache to NGINX. Summarized in one word, I would say Apache is about power and NGINX is about speed. But in the world of web servers, you don't always have to choose. It's actually become very popular to have an Apache and NGINX architecture working together. So first, NGINX can work alone as a standalone web server, or in this way, where they're combined. And in this structure, NGINX is set up essentially as a reverse proxy that will handle and kind of direct all of the requests that are coming in. And then basically, whichever request it is best suited to handle, in most cases, NGINX is significantly faster with delivering static files than Apache web server. So for example, it may be configured for the NGINX web server to handle all of the static requests and then pass along some of the more complex, perhaps dynamic content requests, those things, onto an Apache server. So this has proven to be a popular model. I think the key takeaway here is when you're trying to decide between web server providers, whether Apache, NGINX, or any of the others on the market, it's really a matter of just considering what your particular needs are and what you're trying to optimize for your application or business. So thank you all very much for joining me this evening. Here's some additional resources in case you're interested in learning more. And if you would like to discuss this further, I would be very happy to connect with any of you. Here's my contact information on LinkedIn and GitHub.
Great. I think we have a couple of questions. So Amy, go ahead, take it away.
Yeah, Helen?
Hey, Amy, thank you so much for this talk. I was just curious, because when you said that NGINX is faster than Apache, how big of a difference are we talking about?
Great question. So actually, before I answer, I think it's helpful to just understand a little bit about how this performance monitoring works. It's usually done by benchmarking. So, a given company or person will set up a kind of hardware operating system configuration and then apply, for example, Apache software or NGINX software, and then kind of hit each of those configurations with a battery of requests. And so I think a commonly cited metric is that NGINX performs about twice as fast, up to 2.5 times as fast as Apache when it comes to delivering static content. I think this metric in the particular study that I'm referencing was when the two systems were running up to 1,000 simultaneous connections.
Cool, thank you.
Thank you.
Great. Is there any more questions for Amy? No? Alrighty. Okay, folks. Well, thank you for joining our Tech Talk tonight. We give Amy a round of applause.